Welcome to Statistics Made Simple, and I am Savita Valsang. In this video, I'll define interpolation and extrapolation and some of the methods used, but the main focus will be on the binomial expansion method for one missing value. I'll start with a short introduction. Let x and y be two interdependent variables where x is called the independent variable and y is the dependent variable. And x will take the values which are denoted by x0, x1, x2, so on xn, and y will take the values y0, y1, y2, so on yn. The x values, that is x0, x1, x2, so on xn, are also called as arguments, and y0, y1, y2, so on yn are also called as entries. Now, the definition of interpolation and extrapolation are important one-mark questions. So, what is interpolation? It is the technique of finding the value of y corresponding to a value of x which lies in the range x0, xn. And extrapolation, it is a technique of finding the value of y corresponding to a value of x which lies outside the range x0, xn. Assumptions for interpolation and extrapolation again is an important two-marker. The first point is there are no sudden jumps in the values of the dependent variable from one period to another. Second, there is a sort of uniformity in the rise and fall of the values of the dependent variable. Third, there will be no consecutive missing values in the series. When we solve problems on interpolation and extrapolation, you will be able to identify these assumptions. The two methods of interpolation are graphic method and the algebraic method. In the algebraic method, based on different assumptions, various methods have been developed for interpolation and extrapolation. Some of the methods are the binomial expansion method, method of finite differences, and Lagrange's method. We will confine our discussion only to the binomial expansion method in this video. Under binomial method of interpolation, let us learn under what conditions this method is applicable. First is the x value should be equally spaced. Second, the value of y which has to be estimated should be corresponding to the value of x in the given data. Let us take the example of x taking the values 5, 10, 15, 20, 25. So the x values are marked as x0, x1, x2, x3 and x4. And the y values are 8, 6. Then we have the missing value which is denoted by a blank, 12 and 16. And the y values are denoted by y0, y1, y2, y3 and y4. Now in the above table, you see that the x values are equally spaced. They have a difference of 5 and the value of y which should be estimated corresponds to the value of x 15 in the table. Now if we have to estimate y for x equal to 7 or x equal to 22, this method cannot be used because the value 7 and the value 22 for x does not belong to the table. So the conditions under which the binomial expansion method is applicable can be asked as a two-marker. Let us now learn the steps in the binomial expansion method. The first step is in this method we consider a nth degree binomial, that is y minus 1 to the power n equal to 0, where n is the number of known values of y. The second step, the binomial expansion of the above formula can be obtained as follows. Subdivision A, the subscripts of y will be the number equivalent of the known values of y. For example, if we have y minus 1 to the power 5 equal to 0. So what is 5? 5 will be the number of known values of y which can be obtained from the problem. Suppose this expression has to be expanded. If it was something like y minus 1 whole square, you know how to expand it. But as the powers go on increasing, it is difficult to remember the formula, and hence we have a certain technique. So first, what should we do? If we have y minus 1 to the power 5 equal to 0 and it has to be expanded, you start with y5, y4, y3, y2, y1, y0. So first we write the subscripts of y starting from 5 to 0. Then we have to put a plus and minus sign alternatively for the y terms, starting with the plus sign. So the terms will look like y5 minus y4 plus y3 minus y2 plus y1 minus y0. Next, we have to find out what are the coefficients of the nth degree binomial, and this can be obtained using what is called as the Pascal's triangle. Let us now learn how to form the Pascal's triangle, which will help us in finding the coefficients in the binomial expansion method. So see the table which has 3 columns, that is n, then you have the coefficient and the total. Now n takes the values 0, 1, 2, 3, 4, 5, 6 and it can continue up to a finite number of values of n. The second column is the coefficient and the third column is the total. Now please observe the first row. When n takes the value 0, you're under coefficient, you have to write the number 1 and so the total also will be 1. When n is equal to 1, that is in the second row, the coefficient, you have to write 2 ones as I have indicated, okay, so which will look like a triangle, and when we add these 2 ones, the total will be 2. Then when n is equal to 2, what you have to do is, if you see the orange lines, 2 short orange lines, which I am adding, you will get 1 plus 1 is 2. And on either sides of 2, you should write the number 1, again which looks like a triangle. And for n equal to 2, you observe that the coefficients are 1, 2 and 1, whose total will be 4. Now when n is equal to 3, as indicated by the purple short lines, first you add 1 and 2, you will get the total as 3. Then when you add 2 and 1, you will get the total as 3. And on either sides of these two 3's, you write 1. Now when you add up these values, the total will be equal to 8. Similarly, when n takes the value 4, as indicated by the blue short lines, add 1 and 3 and you'll get the total as 4. 3 plus 3 is 6. 3 plus 1 is 4. And on either sides of 4, you add the values 1. And the total will be 16. Similarly, when n takes the value 5, when we add 1 and 4 as indicated by the red color lines, you get 5. 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and on either sides of this 5 you introduce ones. And when you sum up these values corresponding to n equal to 5, you get the total as 32. So in a similar way, the table can be extended. When we solve problems based on the binomial expansion method and use this Pascal's triangle, you will be able to understand the concept better. But in the exam, make sure that you draw the Pascal's triangle whenever a problem is asked on interpolation. A 5-mark problem based on the binomial expansion method is a sure question in the exam. So starting with the problems, problem 1. Use the binomial expansion to find the most likely index number of the year 2013. So in the table, you have the years as 2011, 12, 2013, 2014 and 2015. The index numbers are 100, 107. Then you have the missing value 157 and 212. So the year you can mark it as capital X, that is a variable, and the index number you can mark it as capital Y, and the values that y take are denoted by y0, y1, y2, y3, y4. So in this problem, we have to find out what is the value of y2 corresponding to the year 2013. Now observe very carefully that the x values are equally spaced, that is, they have a difference of 1. Secondly, we have to find out what is the value of y2 corresponding to the year 2013, and 2013 belongs to the table. So we see that the two conditions for which the binomial expansion method are applicable is satisfied in this problem. So let's start with the solution. The most important step is you have to write, consider y minus 1 to the power n equal to 0. The next step is the number of known values of y is 4. So you see that 4 y values are given. That means n is equal to 4. So which implies y minus 1 to the power 4 is equal to 0. Now, how do you get the next step? So you have to start with y4, y3, y2, y1, y0. Then y4 will have the plus sign. You need not write it. It is understood it is plus. Then the next one is minus, then plus, minus, plus. Then to write the coefficients for n equal to 4, you have to make use of the Pascal's triangle. So when n is equal to 4, the coefficients are 1, 4, 6, 4 and 1. So you get the equation now as y4 minus 4y3 plus 6y2 minus 4y1 plus y0 equal to 0. So whether we write the value 1 or it's not mentioned, it is understood that the coefficient will be 1. Now looking at the table, substitute the values of y. So you get 212 minus 4 into 157 plus 6y2 minus 4 into 107 plus 100 equal to 0. So after you simplify, you will get 6y2 minus 744 is equal to 0, or 6y2 is equal to 744. y2 is equal to 744 divided by 6. Therefore, y2 is equal to 124. You can write a sentence. Therefore, the index number for the year 2013 is 124. Problem 2. The number of births taking place in a village are as given below. Interpolate the missing entry. The years are 2013, 2014, 2015, 2016, 2017 and 2018. The number of births are 320, 300. Then you have the missing entry 280, 278 and 250. The years are denoted by capital X and number of births are denoted by Y, and the Y values are denoted by Y0, Y1, Y2, Y3, Y4 and Y5. Starting with the solution, consider y minus 1 to the power n equal to 0. The number of known values of y is 5 in this case, that is n equal to 5. So which implies y minus 1 to the power 5 is equal to 0. To expand this expression, how do you remember the steps? First, you write y5, y4, y3, y2, y1, y0 and equate it to 0. Then put alternating plus and minus signs and see Pascal's triangle for n equal to 5, and you will get the coefficients as 1, 5, 10, 10, 5 and 1. So after we expand, the expression looks like y5 minus 5y4 plus 10y3 minus 10y2 plus 5y1 minus y0 equal to 0. Substituting the y values, you'll get 250 minus 5 into 278 plus 10 into 28 minus 10y2 plus 5 into 300 minus 320 equal to 0, which implies 250 minus 1390 plus 2800 minus 10y2 plus 1500 minus 320 equal to 0, which implies minus 10y2 plus 2840 equal to 0, minus 10y2 is equal to minus 2840, and the minus signs get cancelled on both sides, or y2 is equal to 2840 divided by 10. Therefore, y2 is equal to 284. Therefore, the number of births in the year 2015 is 284. Problem 3. The following are the annual premiums for an insurance. Calculate the annual premium for a person aged 25 years. Age of person in years are 20, 25, 30, 35. Premium in thousands of rupees are 23. Then you have the missing premium 30, 35. Mark age of persons in years as capital X and premium in thousands of rupees as capital Y, and the Y values are denoted by Y0, Y1, Y2 and Y3. And the solution, consider y minus 1 to the power n equal to 0. The number of known values of y in this problem is 3, that is n is equal to 3, which implies y minus 1 whole cubed is equal to 0. To expand this expression, start with y3, y2, y1, y0 equal to 0. Then put an alternating plus and minus sign, and using Pascal's triangle for n equal to 3, you get the coefficients as 1, 3, 3 and 1. So the expanded form will be y3 minus 3y2 plus 3y1 minus y0 is equal to 0, which implies 35 minus 3 into 30 plus 3y1 minus 23 is equal to 0, which implies 35 minus 90 plus 3y1 minus 23 equal to 0. Simplifying, you get minus 78 plus 3y1 is equal to 0, or minus 3y1 is equal to minus 78, or y1 is equal to 78 divided by 3, or y1 is equal to 26. Therefore, the premium for a person aged 25 years is rupees 26 in thousands. Problem 4. The following data gives the sales statistics of a manufacturing firm in 6 successive years. Estimate the sales in 2016. Year are 2014, 2015, 2016, 2017, 2018, 2019. Sales in thousands are 120, 140. Then you have the missing value blank 180, 200, 225. Mark year as capital X and sales in thousands as Y. Also mark Y0, Y1, Y2, Y3, Y4 and Y5. Solution: consider y minus 1 to the power n equal to 0. The number of known values of y is 5, that is n is equal to 5, which implies y minus 1 to the power 5 is equal to 0. Then write the expansion. Start with y5, y4, y3, y2, y1, y0 equal to 0. Then put alternating plus and minus, and then for n equal to 5, from the Pascal's triangle, write the coefficients, which will be 1, 5, 10, 10, 5, 1. Then from the table, substituting the values, you will get 225 minus 5 into 200 plus 10 into 180 minus 10 y2 plus 5 into 140 minus 120 is equal to 0, which implies 225 minus 1000 plus 1800 minus 10 y2 plus 700 minus 120 is equal to 0. Simplifying further, you will get 1605 minus 10 y2 is equal to 0, which implies y2 is equal to 1605 divided by 10. Therefore, y2 is equal to 160.5. Therefore, the sales in 2016 is 160.5 in thousands. Problem 5. Find the missing entry in the following data regarding the average yield of coconut trees. Age in years 1, 2, 3, 4, 5. Average yield 138, 151, 133. The missing average yield and 296. Mark age in years as capital X, average yield as Y, and the Y values as Y0, Y1, Y2, Y3 and Y4. Solution: consider Y minus 1 to the power n equal to 0. Number of known values of Y is 4, that is n equal to 4, which implies Y minus 1 to the power 4 is equal to 0, which implies Y4 minus 4 Y3 plus 6 Y2 minus 4 y1 plus y0 equal to 0, which implies 296 minus 4 y3 plus 6 into 133 minus 4 into 151 plus 138 equal to 0, which implies minus 4 y3 plus 628 equal to 0, or minus 4y3 is equal to minus 628. The minus signs get cancelled on both the sides and you get y3 equal to 628 divided by 4. Therefore, y3 is equal to 157, and in words you can write the average yield of coconut trees aged 4 years is 157. Problem 6. If e to the power 0.2 is equal to 1.2214, e to the power 0.4 is equal to 1.498, interpolate the value of e to the power 0.3 using the binomial method. Now let us look at the expression under solution. I have written let y be equal to e to the power x. Now in the problem, the x values, if you observe carefully, are 0.2, 0.4, and we have to interpolate for x being 0.3. So the most important step in this problem is first you write let y be equal to e to the power x. And let us form a table with capital X and capital Y, and the x values are 0.2, 0.3 and 0.4 as seen in the problem. Now the corresponding values of Y. are 1.2214. Next, we have to find out the missing value, and then we have 1.4918. The y values are marked as y0, y1 and y2. Consider y minus 1 to the power n equal to 0. The number of known values of y is 2, that is n equal to 2, which implies y minus 1 whole square is equal to 0, which implies y2 minus 2y1 plus y0 is equal to 0. Substituting the values of y, we get 1.4918 minus 2y1 plus 1.2214 is equal to 0, which implies 2.7132 is equal to 2y1, or y1 is equal to 2.7132 divided by 2, that is y1 is equal to 1.3566. Therefore, the value of e to the power 0.3 is equal to 1.3566. Problem 7. Interpolate the missing figure in the following table with the help of a suitable formula. The years are 2014, 2015, 2016, 2017, 2018, 2019. The number of factories are 200, 225, 250, 255. Then you have the missing number of factories, 265. So mark the year as capital X, the number of factories as Y. The Y values are denoted by Y0, Y1, Y2, Y3, Y4 and Y5. Solution. Consider Y minus 1 to the power n equal to 0. The number of known values of Y is 5, that is n is equal to 5, which implies Y minus 1 to the power 5 is equal to 0, which implies y5 minus 5y4 plus 10y3 minus 10y2 plus 5y1 minus y0 is equal to 0. Substituting the values of y, we get 265 minus 5y4 plus 10 into 255 minus 10 into 250 plus 2 into 225 minus 200 is equal to 0, which results in 1240 is equal to 5y4, or y4 is equal to 1240 divided by 5, which is equal to 248. Therefore, the number of factories in the year 2018 is 248. This video on interpolation and extrapolation is an important one. Understand the concepts thoroughly and continue to practice all the problems solved here. Thank you for watching, and in my next video, I will discuss about association of attributes.